Hi, let's go over the next homework assignment. So the next homework is homework number 10. Homework 10. And so in homework 10, we're going to go over 7.1 numbers, 1, 4, 7, 14, and 15. Okay. So number 1 is find the area of the shaded region. Okay, so you have the x-axis here, y-axis here. You have this line that goes through the origin. And you have this curve that also goes through the origin. You have the intersection point, which is 4, 4. You have the graph y equals 5x minus x squared. On the line y equals x. Okay, so that may look like what it is in the book. This is the shaded region right here. And so to find the area of the shaded region, it's just we're going to integrate with respect to x. And so this point is the origin, 0, 0. And so the area, A, is equal to def integral from the leftmost x value to the rightmost x value, from 0 to 4. Of the difference in y values here. So an approximating rectangle could look like this, right? Where the difference in y values is this y value, which is the top function, 5x minus x squared, minus the lower function, which has height x, dx. Okay? And so that equals the integral from 0 to 4 of 5x minus x, which is 4x, but then negative x squared plus 4x. I'm just going to rearrange it there. All right, so you get the negative x squared, you get 5x minus x, which is 4x, plus 4x. So to find the def integral by the fundamental theorem of calculus, you take an antiderivative, which is negative x cubed over 3 plus 2x squared. That's an antiderivative of negative x squared plus 4x. And you evaluate from 0 to 4. And that's equal to, you plug in 4, and you get negative 4 cubed over 3 plus 2 times 4 squared, and then minus, you plug in 0 and get 0. And so that's equal to negative 64 over 3 plus 32. And so 32 is 96 over 3, and so you get 32 over 3 as the final answer. So that equals 32 over 3. Okay? It's negative 64 over 3 plus 96 over 3. And that's 32 over 3. Okay? That's the final answer. Okay. A is that. Okay, so then, so that's the area. Okay, so number 1 is done. Number 4 is next. That's the x-axis, that's the y-axis. Okay, and then, so you have these two functions, this one and that one. So you have x equals y squared minus 4y. X equals 2y minus y squared. Okay, good. We have those two functions there, and we have the intersection point at negative 3, 3. Okay, so there's our intersection point, and this intersection point is the origin. Okay, and a picture. So you want to find the area of the shaded region, which is this region here. Okay, so here our approximating rectangles will be horizontal approximating rectangles. And so that tells us that there's going to be a right function and a left function. Okay, so since this is the right side, this is the right function. Okay, and since this is the left side, this is the left function. Okay, so the area, which I denote by capital A of the shaded region, is a def integral from the smallest y value, which is 0, to the largest y value, which is 3. And then we integrate from the right function I labeled it so I wouldn't get confused. 2y minus y squared minus the left function, y squared minus 4y. Okay, so a good thing to do is to label what the right function and the left function is. That way you don't get confused, right? You might think this is the right function because this is further to the right, but where you're integrating, this is the right function, and this is the left function. Okay, so you integrate definition from 0 to 3 of this minus that. So you get negative y squared minus y squared is negative 2y squared, and then you get 2y minus negative 4y, which is 2y plus 4y, which is plus 6y. So if you combine like terms, you get negative 2y squared plus 6y. Okay? And so this equals, take an antiderivative, negative 2y cubed over 3 plus 3y squared. And you take that an antiderivative like that, and you evaluate from 0 to 3. You plug in 3, you get negative 2 times 3 cubed over 3 plus 3 times 3 squared minus 0. And so then that's equal to 3 cubed over 3, which is 3 squared, which is 9, times negative 2, negative 18 plus 27, and that's 9. That equals 9. Okay? 3 squared times 3 is 3 cubed, which is 27. This is 3 cubed over 3, which is 3 squared, which is 9, times negative 2. Negative 18 plus 27 is 9. That's 9. So the area of that shaded region is 9. Okay, so that's number 4. Okay. Next one, number 7. Okay, sketch a region enclosed by the given curve. Decide whether the interior with respect to x or y, draw a typical approximate rectangle and label height and width, then find the area. Okay, so that's the problems in your book. So the functions are y equals x minus 2 squared and y equals x. Let's draw those two graphs. Okay, so here's the x-axis, here's the y-axis. Here's x equals y, y equals x, same thing. Okay, and so x minus 2 squared is just x squared moved to the right 2 spaces. And so you move x squared to the right 2 spaces, and now the bottom point is here instead of at the origin. And so you just draw the parabola y equals x squared, but starting from the point 2 comma 0 instead of at the origin. You're just taking y equals x squared and translating it to the right by 2 units. So this is y equals x minus 2 in parentheses squared. Okay? So actually, I'm going to extend y equals x more to go further out. This one is going to go up more. It's not going to start tailing back. It's going to be going outward. So that's y equals x, and this is y equals. Yeah. Okay. And so 7 says it's enclosed by the given curve. So that's the region enclosed by the given curves. Draw a typical approximating rectangle. So this is a typical approximating rectangle. Okay, the intersection points, okay, are where the two values are the same. So when y1 equals y2, when x is equal to x minus 2 squared, that's x equals x squared minus 4x plus 4. That's x minus 2 squared. Okay. To subtract x on both sides, you get x squared minus 5x plus 4. Factor out the right hand side, you get x minus 4 times x minus 1. And so that means x equals 4 or x equals 1. Those are the two x values where the y coordinates are the same. That is where these intersection points happen. So when x is 1, y is 1. And when x is 4 here, y is 4 here, because they're both on the line y equals x. So the two intersection points are 1 comma 1 and 4 comma 4. You can test it. When x is 1, y is 1. When x is 1, y is 1. When x is 1, you get negative 1 squared, which is 1. When x is 4, you get 4 minus 2 squared, which is 2 squared, which is also 4. Okay, you test it, it works. Okay, so you have those two intersection points, and labeled height and width. Okay, so the height is the difference in y values. The height is x minus x minus 2 squared. And the width is delta x. Okay? The top function minus the bottom function. This is the top function, and this is the bottom function. Okay, before the other example, there's a right and left function because you were integrating with respect to y. Here we're going to integrate with respect to x, and so there's a top function and bottom function. So A, the area, is equal to the depth integral from 1 to 4, the leftmost x value to the rightmost x value of x minus 2 squared, the top function minus the bottom function, dx. Okay, so you just find that depth integral. It's different from 1 to 4 of x minus 2 squared, which is x squared minus 4x plus 4 dx. That's equal to the depth integral from 1 to 4 of negative x squared, x minus negative 4x is x plus 4x, which is plus 5x, minus 4 dx. Okay? Negative x squared, x plus 4x is 5x, minus 4 dx. And so now you take an antiderivative, which is negative x cubed over 3 plus 5x squared over 2 minus 4x, evaluated from 1 to 4. And so now you calculate that, and you plug in a 4 here, and you get negative 64 over 3, plus, you plug a 4 in there, you get plus 40, minus 16, in parentheses, and then minus, you plug in 1, you get negative 1/3, plus 5/2, minus 4. So that minus that, so it's 40 minus 16 is 24. 24 minus 64 over 3 is minus 21 1/3, which is equal to 2 2/3. Okay, so that's 2 2/3. This first one. Okay, it's 2 2/3 minus this negative 1/3 plus 5/2 minus 4. So that's 2.5 minus 4. That's negative 1.5. So negative 1/3 minus 1.5, and that's equal to negative 2 6 minus 9/6, negative 11/6. It's negative 11/6. So it's 2 2/3 minus negative 11/6. 2 2/3 is the same as 2 4/6. I'm just doing the calculation here, so that's 16/6. 16/6 minus negative 11/6. That's 16/6 plus 11/6. That's 27 over 6. So that's 4.5. Okay. So it's just calculation. You get that's equal to 4.5, right? So that minus that is 4.5. Okay, so that's number 7. Okay, so the next one is number 14. Number 14, sketch the region enclosed by the given curves and find its area. So y equals cosine x, y equals 2 minus cosine x, and so 0 less than x less than or equal to 2 pi. Okay, so let's draw that. Okay, here's the x-axis, here's the y-axis. Let me elongate the x-axis here. So it's from 0 to 2 pi. So pi over 2, pi, 3 pi over 2, 2 pi. So that's from 0 to 2 pi. That's cosine x. And then, so this is the value of 1. And then 2 minus cosine x. So minus cosine x, this would be minus cosine x. You just reflected about the x-axis. That would be negative cosine x, and you would just translate it up by 2. So you would get, so let's say that's 3 here. That's from 1 to 3. And so now you would get get that function. Get that function. Okay. So that is y equals 2 minus cosine x. And this is y equals cosine x from 0 to 2 pi. And so the area we want to find this is number 14. We want to find the region enclosed by the curves. It's this region here. That's the region enclosed by y equals 2 minus cosine x and cosine x from 0 to 2 pi. And so to find the area, capital A is equal to definite integral from the smallest x value 0 to largest x value 2 pi of 2 minus cosine x minus cosine x dx. So you just find that integral is definite from 0 to 2 pi. 2 minus cosine x is minus 2 cosine x dx. Okay, and so you find the antiderivative. That's equal to 2x minus 2 sine x. Okay? And so you evaluate this from 0 to 2 pi. You plug in 2 pi. 2 times 2 pi minus 2 times sine 2 pi. You plug in 0, you get 2 times 0 minus 2 sine 0. That's 0 minus sine 0 is 0. This whole thing's 0. So it's just minus 0. Okay. This is 4 pi minus 2 times sine 2 pi, which is 0. So this is equal to 4 pi. So the final answer is that area is 4 pi. Okay, so there's the picture, and that's A is equal to 4 pi. That's number 14. Okay, and so now number 15. Okay, so number 15 is x equals 2y squared. Okay, then so we have x equals 2y squared, x equals 4 plus y squared, and sketch the region enclosed by the given curves and find its area. So we're going to find the region enclosed by these given curves. It's the x-axis and y-axis. So x equals 2y squared will look like this. X equals y squared is a right-facing parabola. That's x equals 2y squared. Okay, and then x equals 4 plus y squared. That's the same as y squared. X equals y squared would be like this, and then 4 plus y squared would be like moving it to the right by 4 units. So, so you would get a graph that looks like this. And you get that, okay? So then this, okay, so this is x equals 2y squared, and this is x equals 4 plus y squared. And so they intersect at the point where if you plug in y equals 2, you'll see that you get x equals 8. If you plug in y equals 2 here, you also get 8. So when y is 2, they're both x is 8. So 8, comma 2 is an intersection point of the two graphs. And then there's symmetry, so you just try y equals -2, and you get 8 still. So this is 8, comma -2. Okay? Or you could set the two x values each equal to each other and solve for y. So you could say 2y squared is equal to 4 plus y squared. Solve for y, and you'll get y is equal to plus or minus 2. And so they'll each correspond with a point. And so the area we want to find is the area of that shade region. And so we're going to use an approximating rectangle would be horizontal. We're going to integrate with respect to y. So that area is the definite integral from the smallest y value, which is -2, to the largest y value, which is 2, of the right function. That's the right function, 4 plus y squared, minus the left function, which is 2y squared, dy. Okay, and so right I am. That's integral from -2 to 2. That's 4 plus y squared. Let's go there. This is equal to separate from -2 to 2. This minus this, which is y squared minus 2y squared, which is -y squared, and then plus the 4 there. So you get -y squared plus 4 dy. And that's equal to an antiderivative of the integrand function, which is -y cubed over 3 plus 4y. And you evaluate it from -2 to 2. Okay, so now you're just computing a definite integral. And so now you plug in 2, so it's -2 cubed over 3 plus 4 times 2 minus, plug in -2, so you get -2 cubed over 3 plus 4 times -2. And so that's equal to -8/3 plus 8 minus -8, that's positive 8/3 minus 8. Okay, and so the -8/3 minus 8/3 is -16/3, and 8 minus -8 is plus 16. And so you get -16 over 3 plus 48 over 3, and that's 32 over 3. So it's just -16 over 3 plus 16 is 32 over 3. Okay? That's 32 over 3. So the area of that is 32 over 3, and we're done with number 15, and so that's our review of homework number 10.